Last time we've seen this lemma. I want to make some short notes before we start to prove it. So the first note is that actually, because G is monic, we have coefficient 1 here and also 1s in the generator matrix. So first note that this row here corresponds to G, this to G times X until G to the G times X to the N minus R minus 1. Alright. Okay, so at first we note that the rank of G is equal to N minus R. So this, as the rows in G are code words, we have a subspace of dimension N minus R, which gives us that N minus R is at most K. Okay, so now we have one inequality, but we actually want to show that this is an equality. So for the other direction, let's take a code word, and a code word is of the form G times H, because as we remember, the code is generated by G. Okay, and now we want to show that the code has dimension N minus R. So in order to do this, we want to show that we can take representative of H of dimension of degree less than N minus R. So let's see, so we have G times H. We can write it as X to the N minus 1 times some polynomial Q plus some polynomial R with degree R less than N. So again, we see this here as a code word. This is a code word. And this implies that also R is a code word. Now, again, as R is in the code, we can write R as, and also note that R is in the same class as H, because the class of this thing here is 0. R is in the same class as G times H. Alright, and now, as R is in the code, we can write it as G times some H prime, and because the degree of R is less than N, we see that the degree of H prime is less than N minus R. Oh no, this is bad. Let's call this maybe R tilde or tilde. Alright. So we have that. And well, now we see that G times H is the same as G times R tilde, and from that we get that G times as R tilde, which is G times H prime. There we get equal to H prime. So we get a representative of degree less than n minus r. So what we basically get is that, let's maybe write this out, C is the set of G times, say, H prime, where H prime degree of H prime is less than n minus r. And we see clearly that this is a vector space of dimension n minus r, so the dimension of C is equal to n minus r. And we also had that the rank of this matrix is n minus r. So we get that it is indeed a generator matrix. And so we're done with the proof of the lemma.